Assalamualaikum and good day. Uh, in this lesson, I am going to introduce the optimization using metaheuristics. Okay, this is an introduction to optimization. So, optimization is a process of finding the best solution to a problem within a set of constraints. Okay. In optimization, normally we are looking for the best solution or the best configuration of parameters or configuration, the best configuration of the decision variable in order for us to obtain the best or the minimum or the maximum solution for our problem. Okay. Optimization technique are used in a wide range of field. Okay, we know that optimization has been utilized in various fields such as engineering, finance, machine learning, and so on. Right, so we can say that optimization has been utilized in all over uh, the field. All right. So this is the categories of the optimization techniques. Okay. So actually, if we read through in literature, there are a lot of different classification of optimization. Okay, so some of it, the optimization technique is being categorized as a traditional and a non-traditional approach. Some of it has been categorized according to the the origin of the optimization technique, the nature of the problem, and so on. Okay, so one of the categories of optimization technique we can classify using statistical and non-statistical technique. The statistical technique are based on statistical analysis and probability theory, okay, such as what we have learned in design of experiment, especially in the Taguchi, in the response surface methodology, and so on. Okay, and for non-statistical technique, basically these approach are based on heuristics algorithm and mathematical optimization. So for statistical optimization technique, use statistical analysis and probability theory to find the optimal solution for the problem. So as I explained earlier, some of the example response surface methodology, Taguchi approach, and design of experiment, including full factorial and fractional factorial. So these are the category under statistical optimization technique. And for a non-statistical technique, okay, based on heuristic algorithm to search for optimal solution for a problem. Okay, example of non-statistical optimization techniques such as genetic algorithm, simulated annealing, and particle swarm optimization. So if we are, as I mentioned earlier, if we read through the literatures, there are different kind of categorical of optimization technique has been established. Okay, some of it divide the optimization techniques under exact and uh, stochastic approach and so on. Okay, so this is only one of the category of optimization techniques. Okay, this is one of classification for the optimization technique. Okay, so we can divide under statistical and non-statistical. So for statistical, okay, there are a lot of approach here. Some of it, as I mentioned earlier, Taguchi, RSM, factorial. Then for non-statistical, okay, we can divide into exact and approximate techniques. Okay, so the exact will guarantee the optimum solution, and approximate approach will try to find the nearest or the most possible optimum solution for the problem. And for approximate technique, we can divide under deterministic and stochastic. For deterministic, the example are linear programming and integer programming. While for stochastic, we can divide under heuristics and metaheuristics. Okay. Okay, so the example of heuristics, there are a lot of heuristics approach. Some of the example are greedy algorithm. SPT is for shortest processing time in scheduling problem. Then RPW is a rank positional weight. This one is for production line balancing. Okay. Then under meta heuristics, we have a lot of algorithms such as a genetic algorithm, particle swarm optimization, and uh, ants colony optimization. Okay, so these are the meta heuristics category. Then the purpose of optimization is to find the combination of parameters to come out with minimum or maximum target value. Okay. Then function of optimization algorithm to search the parameter combination that come out with the best solution. So the purpose is to find the combination of the parameters, and who are going to find the best combination here is the function of optimization algorithm. So this algorithm will try to find the best combination of the decision parameters, okay, that come out with the best solution. Okay, for example, okay, I have an engineering problem here, okay, which is the helical spring. For identical helical spring, I used to support a milling machine weighing 5,000 pounds. Okay, formulate the problem of finding the wire diameter, okay, coil diameter, and the number of turn of each spring for minimum weight. Right, so we have a problem to find the best combination of this parameter, okay, so that the spring has the minimum weight. Okay, so the first parameter is wire diameter, then coil diameter, and the number of turns. Okay, so we have this example. Right, so the purpose or the purpose of optimization here is to find the minimum weight for the spring. Okay, and the parameters that need to be identified, or the value of the parameters that we need to identify are the wire diameter, the coil diameter, and number of turns. So when we formulate the problem, okay, on top of the uh, target or the initial objective, we have additional constraint here, whereby the maximum deflection must be less than 0.1 inch, shear stress must be less than 10,000 psi, and natural frequency of vibration should be more than 100 hertz. Okay, so these are the design constraints that we need to fulfill. Okay. Then when we formulate the problem for the weight, so this is the formula for the weight, and deflection, the shear stress, natural frequency. So now the algorithm, okay, the algorithm will try to find the combination of the parameters here, D, capital D, N, and small d here, that come out with the minimum weight, but at the same time fulfilling this constraint. Okay, so that is the job or the function of the algorithm in order to find the best combination of parameters to achieve the desired weight, and also at the same time fulfill all the constraint. Okay, so all right, so this is just rephrasing back this initial formula. At this point, we would like to explain that the function of optimization is to identify the parameters for the problem. Okay, the parameters, the value of the parameters, the combination of the parameters here that come out with minimum weight, and at the same time fulfill the design constraint. And another example, okay, a delivery company would like to pick up and deliver the packages from 10 cities. The delivery must begin and return in Kuala Lumpur. Suggest the delivery route with minimum driving duration. Okay, so we have a table here. Okay, there are 10 cities. Okay, so the pickup and delivery start from Kuala Lumpur. So we need to find the route that come out with minimum driving duration. So we have for each of the data here, we have the distance and also the driving duration. So the purpose or the target or the aim of this problem is to minimize the driving duration, but the vehicle must visit all the cities to pick up and deliver the packages. Okay, so this is another example. So for this problem, if we want to solve this problem manually, so it's quite difficult for us, okay, because we need to try and calculate the driving duration one by one. Okay, so if we choose the first route, for example, from Kuala Lumpur to Malacca and so on, and return back to Kuala Lumpur, so we need to calculate the duration. Then another route, okay, from Kuala Lumpur to Ipoh to Butterworth and so on. So there is another duration. And for this problem, the possible route is n minus 2 factorial, okay, which is equal to roughly 40,000 possibilities. Okay, this is for this example of problem. So if we want to calculate manually, so there are 40 possible route that we need to calculate here if we want to solve this problem manually. So it's quite a repetitive task and quite difficult for us to solve this problem by using by using a manual or traditional approach. All right, so next we move to metaheuristics. A metaheuristic is a higher level procedure that we design to find, generate, tune, or select a solution that may provide a sufficient good solution to an optimization problem or for a machine learning problem. Okay, so this is the metaheuristic. This is a high level procedure, okay, that designed to optimize the problem, right? So some of the properties for metaheuristics. Okay, metaheuristics are strategies that guide the search process. The goal is to efficiently explore the search space in order to find near optimal solution. Okay, so when we are using metaheuristics, we cannot say that the solution that we obtain are the real optimum, the most optimum, because meta-heuristic is not guaranteed that we will obtain the real optimum or the most optimum solution. Okay, technique which constitute a meta-heuristic algorithm range from simple local search procedure to complex learning process. Meta-heuristic algorithms are approximate and usually non-deterministic. So meta-heuristics are not problem specific. Okay, meta-heuristic are approximate approach. So it just give the approximate optimum solution, not real optimum solution. Okay, and meta-heuristics are not problem specific. Means that meta-heuristics is not developed for a particular problem. So in general, we can use meta-heuristic to solve all the optimization problem, right? Okay, so this is one of the figure that showing the subset of meta-heuristics, which consists of the population-based approach, also evolutionary algorithm, including the trajectory approach, local search, and so on. So this is only one of the category of the one of the classification of the meta-heuristics. So some of the example of meta-heuristics algorithm, if we look under evolutionary algorithm, are genetic algorithm, genetic programming, evolutionary programming, differential evolution. Then the particle swarm as well. Particle swarm is one of the approach that under the naturally inspired algorithm, including ant colony optimization, simulated annealing, and so on. Okay. So again, what is metaheuristics? So it is an optimization algorithm used to solve complex problems. It explore the search space by iteratively improving a candidate solution. Okay, so it's based on natural processes of evolution, swarm intelligence, and other biological and physical processes. So normally, metaheuristics algorithm inspired by the surrounding phenomenon. Okay, for example, the natural evolution, okay, the swarm intelligence, the physical activities, and so on. Okay, designed to be flexible, robust, and adaptable to various optimization problems. So this is meta heuristics. So this is the categories of meta heuristics. Okay, single solution based and population based. Okay, so the difference is in terms of the number of candidate solution that being tested for every iteration. Okay, in single solution based, only one solution is being used, or one candidate solution is being used to explore the entire search space at one iteration. Okay, but for population-based meta-heuristics, a set of candidate solution is being assigned to explore the search space. The search space here is referred to the possible combination of decision variable that we want to test. Okay. So some example of meta-heuristics algorithm. Okay, the most popular is a genetic algorithm, particle swarm optimization, ant colony optimization, simulated annealing, tabu search, and there are many more. Okay, so these are some of the popular meta-heuristics algorithm. This is the strength and weaknesses of meta-heuristics algorithm. In terms of strength, the algorithm can solve complex problem. Okay, so this is the high level optimization approach. So it can solve complex problem, and it also can handle noisy and also incomplete data, and it can find solutions that are close to optimal or satisfactory. And again, in meta heuristics, the algorithm are not guaranteed that we will find the real optimum solution, but the solution that will be provided are satisfactory, although that one is not a real optimal solution. Then in terms of weaknesses, okay, may not guarantee global optimality. So as I mentioned earlier, the meta heuristics will not guarantee to find the real optimum solution. Okay, it will find the close to optimal or near optimal solution, which already good enough to be used in the design, in the decision making, and so on. Then it may require problem specific modification. So for meta heuristic algorithm, so we need to write a fitness function to solve a particular problem. For example, we want to solve the spring problem, so we need to write the objective function and also the fitness function for the problem. If we want to solve a vessel design problem, so we need to write the fitness function for that problem, and so on. So we need to modify the algorithm according to our application. Okay, this is the basic step or general step in meta heuristics. Okay, majority of meta heuristics algorithm will utilize this flow. Okay, we begin with initialization. Okay, then evaluation. So initialization is basically to create a set of random solution, and also to define the certain parameters that will be utilized in the algorithm. And then evaluation is to evaluate the solution that has been generated in earlier stage. And then reproduction means that based on the result that has been obtained from evaluation, so the algorithm will reproduce the new solution, okay, based on the particular or specific algorithm that we utilize. Then finally termination, so it will terminate or stop the iteration process once the termination criteria is fulfilled or satisfied. Right, so initialization will define required parameters, generate initial population of candidate solution, then the size of population depend on problem that we solve. Then evaluation, we evaluate each candidate solution, then assign a fitness value to each solution based on how well it solved the problem, and the fitness function is problem specific. Reproduction, to create a new candidate solution that are different from original solution. Reproduce the population using specific operator or mechanism. Then the operator or mechanism are dependent on the algorithm. Then for reproduction, for example, here the genetic algorithm, they use crossover and mutation operator in order to conduct reproduction. In a particle swarm, they use P-best and G-best using dedicated equation. So they update the personal best and global best solution using a dedicated equation. And for ants colony optimization, they update the pheromone in the system so that the new solution can be reproduced. Then finally for termination, so determine when to stop the algorithm. So termination criteria can include a maximum number of iteration, minimum level of improvement, or maximum runtime. So we can set when to stop our iteration and what criteria that we can use. So the algorithm stop when termination criteria are met. Okay, normally in a regular or in a standard meta-heuristic, we just set the termination criteria using the maximum number of iteration. For example, we set our iteration, the maximum iteration is 300. So when the number of iteration reach 300, so it will automatically terminate.